Welcome back, everyone. Here's a new section, section 7.3, equations in quadratic form. Some little insight. Remember back in unit 4, we used substitution to help us in factoring polynomials of higher order. So when you look at example 1, it says parentheses 2x squared minus 5 closed to the power of 2 minus 16 parentheses 2x squared minus 5 close the parentheses plus 39 equal to 0. The first thing I notice is that the insides match. So the first thing we're going to do, since they've already used x's in the parentheses, I'm going to use another letter for substitution. I'm going to use the letter A since it's the first letter of the alphabet. So A is going to represent 2x squared minus 5. And wherever you see 2x squared minus 5, that is going to be replaced with an A. So now we become a squared minus 16a plus 39 equal to 0. So if you've noticed, we took a higher ordered exponent because if I were to square this bubble out, I would have an x to the 4. I've broken it down to a simple factorial polynomial here. So numbers that multiply to be 39 that add to negative 16. So now is where you have to think of your factors. Well, 39 is, if you add 3 and 9, that gives you 12, and 12 is divisible by 3. So I can go with 13 and 3 multiply to be 39. And in order to get negative 16, they now need to both be negative. So I'm going to break this down by factoring to become a minus 13 and a minus 3. So a is going to be a 13. A is going to be equivalent to a 3. Now remember, a was not part of the original problem. A is a representation of 2x squared minus 5. So now we're going to substitute back. 2x squared minus 5 is set equal to 13. 2x squared minus 5 is set equal to 3. We're going to do our math. We're going to add 5 over. So 2x squared equals 18. Divide by 2. X squared equals 9. And then take the square root of both sides. So when you take the square root of both sides, you have two situations. It's a plus minus, square root of 9 is 3. You're going to repeat the same process with the second equation. You're going to add 5 over. So you get 2x squared equals 8. Divide both sides by 2. So you get x squared equals 4. And then again, take the square root of both sides. And remember, you have a plus minus situation, plus and minus 2. Remember, we have 4 solutions in this problem because if we go back to the original, x squared, and if I square it, 2 and 2 make 4. So there should be 4 solutions to their problem, which means that this equation, if we were to graph it, would cross the x-axis 4 times. Okay, example 2. Example 2 says p to the 2/3 power minus 2p to the 1/3 is equal to 8. Obviously, I was not going to give you an easy problem. First thing we need to do is move the 8 over so we're in descending power. So we have p to the 2/3 minus 2p to the 1/3 minus 8 set equal to 0. So obviously, we don't deal with exponential fractions. So we need to factor this out using our rules from exponents. So I'm going to rewrite this as p to the 1/3 with a 2 on the outside minus 2, and I'll put p to the 1/3 in parentheses so it matches the first one, minus 8 equal to 0. When we go to here, we see that both parentheses are the same. Since they use p's, I'm going to use the letter x this time. So x is going to represent p to the 1/3, which is actually the cube root of p. So now I see x squared minus 2x minus 8 equal to 0. So we started with fractional exponents, and now we have numbers we can factor out. So again, we need numbers that multiply to be negative 8, that add to be negative 2. Well, 8 is 4 and 2. In order to get a negative 8, one has to be positive and one has to be negative. In order for them to add to be negative 2, the 4 had to be negative. So now we become x minus 4 times x plus 2 equal to 0. Break it out. X is equal to 4. X is equal to negative 2. but x was not part of our original problem. We used the letter p. So now we're going to substitute back in. But I'm going to use the cube root situation. So I'm going to say that the cube root of p is equal to 4. Cube root of p is equal to -2. And remember your rules of cubic functions. If you have a cube root, to break it out, you raise it to a power of 3 to both sides. So raising this to a power of 3, the right to a power of 3. So p is equivalent to 4 cubed, which is 64. Parentheses, parentheses, power of 3's for both. So p is equal to, remember, it's -2 times itself 3 times. So 3 negatives in a row, you are still negative. So you are -8. Okay, example 3. First thing I notice about this problem, it says x minus the square root of x minus 12 equal to 0. Back in unit 4 and in unit 6 that we finished, anything dealing with radicals, we knew that problems that had even index values, just like this one does, once you find your solution, you need to check it back in the original problem to make sure it works. So I'm going to make this plain x, the whole x, convert to the radical x. First thing I'm going to do is I'm going to rewrite this x as the square root of x in parentheses raised to a power of 2 minus, I'm going to write square root of x minus 12 equal to 0. Now I can see that the parentheses both match for both of them. Since the variable x was used already, I'm going to represent the radical x by using the letter a. A is going to represent the square root of x. So now we can break down our problem to become a squared minus a minus 12 equal to 0. Now this is a problem that we can actually factor out easily. So we need numbers that multiply to be -12 that add to be -1. So when I think of 12, I always think of 4 and 3 to start. And in order to get to -1, 1 had to be negative. So the 4 had to be negative. So we can see -4 times the 3 is the -12. -4 plus the 3's are -1. So we break down to a minus 4 times a plus 3 equal to 0. Solve the solution. So we get a is equivalent to 4 and a is equivalent to -3. But a was not part of your original problem. A is representing the square root of x. So we're going to substitute back in. Square root of x equals 4. Square root of x equals -3. Square both sides because it's a radical, 2. It's a square root of x. Remember, the index is 2, so we raise it to a power of 2. So x is equal to 16. Raised to a power of 2. X is equal to +9. So we have two possible solutions, x equal to 16 and x equal to 9. So remember, because I said it was an even index, we need to check it. So I'm going to rewrite my original equation, x minus radical x minus 12 equal to 0. I'm repeating it again, x minus the radical x minus 12 equal to 0. I'm going to first test the 16. I'm going to write 16 minus the square root of 16 minus 12. Does that result in 0? Well, 16 is still 16. Square root of 16 is a 4. So 16 minus 4 is 12. Minus 12 equals 0. So 16 is one of our solutions. Now we need to verify if the 9 is a solution. We're going to plug in the 9 now. So 9 minus the square root of 9 minus 12. Does it result in 0? 9 comes down. Square root of 9 is a 3. 9 minus 3 is 6 minus 12. Well, -6 does not equal 0, so we do not keep the 9. This is called an extraneous solution. Make sure anytime there's a problem that has an even index, it could be a square root, it could be a 4th root, a 6th root, an 8th root. You need to verify your solutions back in the original to see if it is an actual solution to the problem. Example 4 says 4x to the 4th plus 7x to the 2nd minus 2 equal to 0. This problem right here, we don't really need to use substitution method since the exponent is a power of 4 and the middle one is a power of 2, which means half of 4 is the 2, that is our middle piece. We can go in straight to factoring. So I'm going to put 2 parentheses. And those of you that have had me in the past, I do Colombian method of factoring. So the first step is you're going to take the first solution, the value of 4, and you're going to plug it into both pieces. of your parentheses. Power of 4, I'm going to split it in half. I'm going to make them power of 2. That is step 1. Step 1, you're going to take the first coefficient, the leading coefficient, and put it in the parentheses for both of them. And then split the exponent. Step 2, you're going to take the first number and multiply it times the last number. And I become -8. I'm going to find numbers that multiply to be -8 that add to positive 7. Well, the only way to get to 7 and a number of 8 is 8 and 1, where the 1 is the negative. So I'm going to become positive 8, -1 inside. We're going to set each of these equal to 0. So I'm going to write 4x squared plus 8 equal to 0, 4x squared minus 1 equal to 0. We're subtracting 8 over. So you get 4x squared equals -8. Divide by 4. So you get x squared equals -2. Now, because it's negative, and when we take the square root of a negative number, remember, think of it as square root of 2, square root of -1. So x is equal to positive and negative I radical 2. That is the first solution. There's 2 imaginary answers here. You go to the second one, add 1 over. So you have 4x squared equal to 1. Divide both sides by 4. So x squared equals 1/4. If you take the square root of both sides, it means you square root of the numerator and denominator. So x is equal to positive and negative 1/2. Again, the starting coefficient had a power of 4. The variable had a power of 4, which means there should be 4 solutions. In this problem, we actually had 2 answers where it hit the x-axis and 2 values that are floating in the air.